Okay, P5.3, electrical power. This one is going to get quite maths heavy, so I'm going to go quite slowly. So if we remember our definition of voltage, or potential difference, to give it its more accurate name, is equal to the amount of energy per unit charge. Okay? Energy divided by charge. That's the first equation. That's equation number 1. So we'll label that up as equation number 1. Equation number 2. We said that current equals charge per second. Okay. That's equation 2. Now, if I want to know how that's linked to power, I need a third equation, and we need to remember power from the energy unit, and we need to say that power equals energy divided by time. So that means that I can put both of these two equations into this equation. So if I make energy the subject of this equation, so making energy the subject of this equation is going to be energy equals voltage times charge. So E equals VQ. And if I wanted to make where Q is the charge, remember, E is the energy and V is the voltage. On this one, I is the current, Q is the charge, and T is the time. P for power, E for energy, T for time. Okay, so all I've done there is just put the symbols in so I don't have to write it out every time. So the next thing I need to do is I need to make time the subject of this equation. So I know that time is equal to Q divided by I, so T equals Q divided by I. And then I want to put 1 plus 2, so my two equations, and I want to put them into equation 3. And that will give me equation 4, which is power equals VQ over Q over I. Okay? Now, if you divide by and then divide by again, that's the same as times in by, so I can put the I on the top. So that equals VI Q divided by Q. And if you've got something on the top and something on the bottom, then they cancel out, which means that power equals IV or VI. It's the same thing. Okay, but we're not going to stop there. We're going to carry on. So we're then going to say we're going to draw in another equation. So this is going to be equation 5. And equation 5 was Ohm's law, where we said that potential difference equals current times resistance. Okay, so that means that I can put 5 into 4 to give me 6, to give me equation 6. So this is equation 6 now. So I need to rearrange it to make V the subject. So I can then say that V equals IR. And then I put that IR into here. So I then say that V